Welcome to FlexGrid Explorer, a CSS layout playground built for students, front-end developers, and anyone learning how Flexbox and CSS Grid behave visually. This project uses React, TypeScript, Tailwind CSS, Framer Motion, and reusable UI controls to turn layout properties into an interactive preview and generated CSS. The user can experiment with layout values, see the result instantly, and copy the final code. We are now on the FlexGrid Explorer workspace. The top bar shows the project name, the current layout mode, a button to show or hide the code panel, and a reset button. The left panel is the control area. The main workspace is the preview canvas, and the lower panel shows generated CSS. By default, the app opens in Flexbox mode. The control panel starts with a segmented switch for Flexbox and Grid. This lets the user change the entire layout model without leaving the page. Now we are using Flexbox mode. The Flexbox controls are grouped into container settings and item settings. In container settings, the user can change flex direction. When we choose row, items flow from left to right. When we choose row reverse, the order visually reverses. When we choose column, the items stack vertically. When we choose column reverse, they stack in the opposite vertical direction. The preview updates immediately because the selected values are stored in React state and applied directly as inline CSS styles on the preview container. Next, we adjust justify content. This controls how items are distributed along the main axis. Flex start places them at the beginning. Flex end moves them to the end. Center places them in the middle. Space between spreads them with equal space between items. Space around and space evenly create different spacing patterns. Now we adjust align items. This controls alignment on the cross axis. The user can choose flex start, flex end, center, stretch, or baseline. As each option changes, the preview boxes move or stretch based on real Flexbox behavior. Next, we change flex wrap. No wrap keeps all items on one line. Wrap allows items to move onto additional lines when there is not enough room. Wrap reverse moves wrap lines in the reverse direction. Now we use the gap slider. The gap slider changes the spacing between items in pixels. As the user moves the slider, the preview updates and the generated CSS updates with the new gap value. Next, we change the item count. The item count slider can create from 1 to 12 flex items. When more items are added, the preview creates numbered boxes automatically. When fewer items are selected, extra boxes are removed. Now we open item settings. Each item has its own controls for flex grow and flex shrink. Flex grow controls how much an item expands when extra space is available. If one item has a larger grow value, it takes more available space than the others. Flex shrink controls how much an item can shrink when space becomes limited. This helps the user understand how individual flex items respond inside the same container. The preview boxes animate as the values change, making the layout behavior easier to see. Now let us switch to grid mode. The sidebar changes from Flexbox controls to grid controls. The preview also switches from display flex to display grid. The first input is grid template columns. By default, the grid uses 3 equal columns. The user can type values such as 1 fraction, 1 fraction, 1 fraction, repeat syntax, fixed pixel values, or mixed column sizes. As the template changes, the preview grid updates to match the type CSS. Next, we adjust grid template rows. This controls row sizing. The default value is auto, but the user can enter custom row patterns to explore how grid rows behave. Now we adjust the gap slider. Just like Flexbox mode, this slider changes the spacing between grid items and updates the generated CSS immediately. Next, we choose justify items. This controls how each grid item aligns horizontally inside its grid cell. The options are start, end, center, and stretch. Now we choose align items. This controls vertical alignment inside each grid cell. Again, the user can choose start, end, center, or stretch. Next, we adjust grid autoflow. The user can choose row, column, dense, row dense, or column dense. This demonstrates how CSS Grid places automatically positioned items. Now we change the grid item count. The item count slider can create from 1 to 16 grid items. The preview updates instantly, showing how the same grid rules place a different number of boxes. Now let us look at the preview canvas. The preview area contains a dashed layout container with numbered items. In Flexbox mode, the container uses real Flexbox properties from the current configuration. In grid mode, it uses real CSS grid properties from the current configuration. The preview is not a static illustration. It is the actual CSS behavior being applied live. The boxes use repeating color styles and numbered labels so the user can easily track order, spacing, and alignment. Now let us open the generated code panel. The generated CSS panel shows the container class with the exact layout properties currently selected. In Flexbox mode, it generates display flex direction, justify content, align items, flex wrap, and gap. If individual items have custom grow or shrink values, the code also generates separate item classes for those changes. In grid mode, it generates display grid template columns, grid template rows, gap, justify items, align items, and grid autoflow. When the user selects copy code, the app writes the generated CSS to the clipboard and shows a copied confirmation. This makes the tool practical for learning and for quick prototyping. The user can experiment visually, then take the generated CSS into a real project. Now we use the reset button. In Flexbox mode, reset restores the default flex configuration, row direction, flex start justification, stretch alignment, no wrap, 12 pixel gap, and 4 items. In grid mode, reset restores the default grid configuration, 3 equal columns, auto rows, 12 pixel gap, stretch alignment, row autoflow, and 6 items. On smaller screens, the interface adapts. Instead of showing preview and code at the same time, the user can switch between view code and view preview. This keeps the layout usable on mobile devices. The project also uses framer motion for transitions between modes, item changes, panel changes, and copied states. These animations help the user understand that the layout is changing in response to their controls. Behind the scenes, the app is built around strongly typed layout configuration objects. Flexbox settings are stored in a Flexbox config object, while grid settings are stored in a grid config object. Each control updates part of that object, and the preview and code viewer both read from the same state. This is why the visual preview and generated CSS always stay synchronized. And that is FlexGrid Explorer, an interactive CSS layout lab for learning Flexbox and Grid through direct manipulation, live preview, and copy-ready code. It turns abstract CSS properties into something visual, practical, and easy to understand. Thank you for watching.